That one's kind of off center. Really screwed this one up when I joined them. I don't know if I should. Man, this stuff's strong. I wonder if I can shift it. Wow, I can't even shift it. That's how strong this stuff is. I'm squeezing as hard as I can. Probably 30 to 40 pounds of force. And I'm not able to shift it. So that's a good sign for the strength of these composite fingers I'm making. I mean, I'm squeezing really hard. And they won't budge. I'll just have to kind of fill that. Oh, this sucks. I don't know. I don't want to redo this one. I think I should. Wonder if I could pry it apart with this knife. I don't like it being that off-centered. Okay, I tore that out. Ooh, this is scary. This thing took me like 4 hours to make, so I hope I don't destroy it in the process. Or cut myself. Like, don't try this at home. This X-Acto knife would go right through my finger with the amount of force I'm using. That's why I'm trying to twist upward, but it's still scary. I mean, this is the kind of stupid stuff that gets people hospitalized. Like, where was that? Oh yeah, risking my fingers, putting great amounts of force with an X-Acto knife. Maybe I should just score it for a while. Try to weaken it. I'm trying to split this in half because I misaligned the two halves when I joined them and glued them together. And so the finger is kind of off, and I don't want to kind of lower my bar like that. I want to make everything high quality, and that might even affect negatively the motion of the finger if I don't watch it. So it's just better to get it taken care of right away. You know what? I don't think I have to open up everything. I think that's good. I just had to realign the front. Like so. I want to tape this thing shut so I don't have to hold it after I glue it. Okay, so you know what? Getting rough with this finger really showed me how strong this finger is. I mean, that was insanely strong. You could see that. Like, you could stand on this finger all day and it wouldn't break, so it's really encouraging. And especially encouraging considering, I mean, check out how thin this is, guys. This is like an eggshell. It's literally the width of this. It's just single layer of sewn. You can't even see this on the camera. It's the width of thread, and it's that strong. It weighs nothing. So that's why composite construction is the best for robotic bones, and that's why if you look at like bikes for Olympic bikers, it's always composite because they go for lightweight. Even some rocket stuff, like certain rocket things, they're going with composite materials even for that. Kayaks, I know. Some of those are composite as well for like racing. Cars are composite a lot of times. Okay. Just gonna get a little bit of clay in the gap. This didn't close up as well as I'd like. Really get some gloves on because it's going to start getting messy as soon as I start getting involved with glue and clay. And I don't like getting my hands real messy because then everything I touch gets messy and then I get frustrated and then there's more time spent cleaning stuff up. It's nice when you can just take off your gloves, put on a new pair, have clean hands right away. Have to spend time scrubbing off whatever crazy things you got on your hands. Plus, you don't really want to be soaking up a lot of chemicals into your skin. I'm working with epoxy, crazy glue, all kinds of chemicals, so you gotta be careful. See, the reason I've got to get rid of any gaps is because these bones need to be airtight. As soon as they become airtight, the air inside of them actually serves as a strengthening agent. So if you were to try to crush it, the air has nowhere to go, and so the air itself forms a lot of strength. Similar to a bottle, you can't crush it because it's full of air, so that prevents the bottle from being as easily crushable. So by making this airtight, it's like tightening a bottle. You can't crush it as easily. It's really important that I get rid of any pinhole leaks. Coat these bones thoroughly with epoxy. Actually, a lot of the designs for my robot's skin, ligaments, and muscular actuation systems are going to heavily be tapping into embroidery and sewing related techniques. So take that, people laughing that I know how to tailor. Actually is going to come in handy for something awesome, making a robot. And I think this is going to be like the first ever robot that's using so much tailoring type stuff. I mean, like the entire robot is made out of, first of all, upholstery thread and glue. Like all these bones are made out of upholstery thread and glue. So that's going to be like really weird. I mean, usually robots are made out of, you know, aluminum or carbon fiber, plastic. So I'm like doing things in a very unorthodox way, but I'm very excited about the techniques I've come up with and that I'm planning to be implementing and that I've already implemented. They're really cool and outside of the box. See, this is a bone I actually did cut in half after, you know, wrapping it with the crazy glue and upholstery thread. And you can see the clay inside. I remove all the clay because the clay is extremely heavy. So, I mean, it's really tedious. You're probably going to be rolling your eyes watching this, but everything about this is tedious. I mean, how could it not be? I'm dealing with these tiny little bones of a finger. I mean, most people, if asked to make that, would be like, I don't know how to make something that tiny. I'd need a 3D printer or whatever. So, which, by the way, I did consider using a 3D printer, but I can't afford one right now, and with all the stuff I'm going to need to be printed, that would be pretty expensive. And as you've seen, these are a lot lighter and stronger than anything a 3D printer could currently produce. Composite materials are way better than just, you know, melting plastic into a shape. That would make something really weak, like a toy. This robot's, you know, it's supposed to be state of the art, and so 3D printing wouldn't cut it. Oh my goodness. No! That's not good. No, 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 no. That's the first time that's ever happened to me. Okay, I'm gonna need to reinforce this before I dig it out. Do that in the future. So yeah, this is gonna need to be epoxied first to really solidify the shell so it doesn't unwind when I go to dig out the clay from the inside. I'm going to do that from now on as the first step. So with that in mind, when I epoxy anything, I like to epoxy a lot because I waste a pair of gloves every time I do it. I realized that applying the epoxy with the tip of my X-Acto knife is really slow. And so I just roll these bones around in my fingers like this with the epoxy on my fingertips, and it really nicely applies epoxy evenly over everything. Incredibly messy though, so I always just throw the glove away right after. Where's my epoxy? There we go. Stuff is super messy, so you gotta be careful how you do this. I don't really want to start with too much. This stuff dries so fast. Just do a small amount, like small batch at a time. Because once you get sidetracked with something along the way, then you end up the batch starts to cure, and you still haven't applied it yet. You haven't finished applying it, so it causes problems. It's so cool imagining what it's going to be like when these bones someday are moving and lifelike. It's just crazy to think that something I made out of string and glue is going to be able to someday do what my hands are doing now, for example. It's just so inspirational, creating something that cool. Now comes the sad part. I gotta waste these gloves. There's no way to reuse them after that. But they definitely serve their purpose. That saves so much time compared to if I were to have applied the paint any other way. Or not the paint, the epoxy. What's nice also about using post-it notes to mix the epoxy on is you just take off the top post-it note and you're good to go. No cleanup, no mess. So this whole time I've had to brace these bones with clay underneath to form the correct curvature because this clay is very flexible. But I think now that I've coated the top half of this bone, it's safe where it's not going to flex anymore. But, ooh, I mean, it was a 6-hour job, so I don't know if I want to risk it moving. Nah, it ain't gonna move. What do you think, guys? Is it gonna move? Have you made the hand yet? Well, I sculpted the hand in clay, and these are the fingers coming out one at a time in their composite molds of that clay. And I just put on a coat of epoxy on them, and they're incredibly strong. And yeah, so after a finger's done, I just cut it in half, take the clay out, and go from there. But yeah, I haven't like made a hand that can do this. Like I'm building right now. I'm in the creation of bones phase, and even though some of these fingers are just about ready, oh, I can also show you guys this. Um, Here was one of the early fingers I made just as a prototype, and you can see how I'm going to rig it. So it's just string, and you can see just by me pulling the string, it does move it. Now, obviously, I mean, this is just really rough. It's got duct tape and whatever just to hold it in place, but it was just a proof of concept to show that just by taking string and then bringing them to the joints, you can actuate the joints. And that proved my drawings, what I had visualized, will work. And then it's just a matter then of connecting your little servo motors to the string, and then that turns the string, which then moves the joints. And if these motors go really fast, you know, you can have the joints do this, like even maybe faster than human speed. I don't think the fingers will be as strong as a human because these only have 20 pounds of force-inch torque. They're just cheap hobbyist servo motors from Hong Kong, but you know, I'm not going to get into the big honking motors until I need them for muscles like the biceps, the thighs, things that pull all the joints eventually move by string. Then yes, it's basically going to use the same type of idea as the human body. Our bones are connected to by ligaments and muscles, and I mean that's basically strings. And so I'm not modeling this out of the same ideology of I'm an engineer and this is what I learned in engineering school. This is how you make things out of nuts and bolts and metal. I'm coming at this from no background in engineering, just a background in sculpture and tailoring and art. And I'm not even going to use a single screw, a single nut or bolt on this entire project. It's going to be all made of string, and then obviously your circuitry and motors, but this is going to be a very non-mechanical robot. And well, I don't know if that's the right terminology, but it's not going to be like built like a vehicle or some big industrial looking thing. It's going to look very natural, and by having an actual bone system and actual muscles, it will move a lot more human-like because it's actually constructed in a very similar way to the human body. So, you know, that's the holy grail of a humanoid robot, is making it move like a human. And I'm going to have a huge advantage in that department by studying anatomy and emulating what a human's like. What do you use what do you use as the computer to control the robot? I'm actually thinking of just using a small fanless computer, like an actual computer, like a desktop computer, just a mini one. They make mini fanless computers, and they're fanless because they don't give off a lot of heat. They're very tiny. They're made of the same parts as like an iPad or a tablet. I mean, I could even probably use a tablet, but I mean, for initial testing, I could just hook it up to my main desktop computer, but I'm gonna end up having an onboard computer, and I'll just use either tiny tablet or, you know, basically tablet type of thing. Is your girlfriend supportive of having a robot slave? Yeah, definitely. I don't know if she's supportive of me spending a lot of time with this instead of doing something else that could be more lucrative. But I think that this will be lucrative. I just have to convince her of that. Like, once my stream and YouTube get big, I should be able to make pretty good money from this. Just from building a fan base around this project. I mean, once this robot can start doing some cool stuff, like even just doing this, I mean, people are gonna start blowing up all my stuff. It will get pretty famous pretty fast, I think. If it is as awesome as I have it envisioned. Obviously, 20 years from now, if everybody had a personal robot, nobody would care, but the fact that this is kind of cutting edge technology still. Do it together, how romantic. You know, I kind of believe it's better to keep work and relationships, like personal relationships, separate. I just don't want to risk like fighting. Like, I've been a boss before, like I've had employees before, and I'm kind of a hard boss. Like, I want everybody to work really hard, and maybe I'm sometimes too critical. I'm not like sweetheart when I'm a boss. Once I get in work mode, I can get like pretty intense, and yeah, I don't want her hating me by being an employee slash partner or whatever. Probably just best to not really combine the two. You could work on an arm and leg each, but after one might be shorter than the other. Yeah, I'm really scared about that. I'm gonna have to measure a lot to make sure that that everything's the same, like the correct length. I mean, if you watch me long enough, you'll see I'm really tedious about detail. Attention to detail is super important to me. So most likely I won't do something that massive of a mistake, but we'll see. Okay, so now I need to make this thing easy to hold. That's like way too wide of a grip. I want it to be like a pen, like, you know, like a pen, a tool. So, pretty cool that I'm inventing a tool live on Twitch. You guys are seeing an invention happen. Patent pending. Except not. You can patent this if you want. Just don't sue me for using my own invention. I'm a patient guy, but I want to make these bones fast as I can so I can proceed. I don't want to be sculpting the bones for the next, 2 years. I want to get them done as fast as possible. So every day I'm going to be thinking of ways to improve it. At one time I was just using a single string going around, and that works okay for the finger bones, but these bones are huge. This one took me 6 hours, and I want to get that down to half an hour. Like, I just want to be able to go, like, put the string on so fast. String Sharpie! That's hilarious! Exactly. Seriously though, this could have some applications in 3D printing. Like, if you could mechanize this, so you just, you have a machine like putting on the string onto glue. It is a lot like 3D printing the way I'm doing this. And just put string down. Like, people want composite material 3D printing, so this could actually be a thing, but You know, I'm kind of done inventing new things, so you guys can go patent this if you want. Make the world's next 3D printer this way.